2G, mixing operations, dealing with whole numbers and decimals. So when we're talking about mixing operations, we're talking about putting addition, subtraction, multiplication, division, exponents, and radicals all together in the same equations. Now, operations, that's the term that we use for the different actions in mathematics. Addition is an operation. Subtraction is an operation. Taking the root, the radical of something, the square root, the cubed root of something is an operation. So mixing the operations, basically, you've dealt with it before, and you called it order of operations. Basically, what operations, which actions get priority or precedence? Which ones do you do first? Which one's second? Which one third? And to do that, you've probably seen PEMDAS. Please excuse my dear Aunt Sally, right? PEMDAS, which tells you that first you deal with parentheses. Then you deal with exponents. Then multiplication. Then division. Then addition. And subtraction. So, parentheses, exponents, multiplication, division, addition, subtraction. Now, one concern that I have with this is that it tends to throw people off because they get in the habit of, we've got to do parentheses first, then we've got to do exponents, then we've got to do multiplication, then we've got to do division, then we've got to do addition, then we've got to do subtraction. And that's not entirely correct. Multiplication and division are essentially the same operation. And they happen at the same time. They have the same priority. So when you get to the points you've got through your parentheses and your exponents, you're going to deal with multiplication and division at the same time, working left to right. So you're just going to start at the left of the problem and work your way to the right, doing all multiplications and divisions as you get to them. Don't do all the multiplications first and then do the divisions. Start from the left and work your way to the right, doing all multiplications and divisions as you come to them. Same thing with addition and subtraction. You're going to work those left to right. So don't do all your additions first and then go back and do all your subtractions. Start with the left of the problem and just work your way across, doing any addition or subtraction as you get to it. Okay? Unless there's a parenthesis or something which causes you to do it ahead of time. Now, this can be confusing to people. So there are some other ways that this is mentioned. I've seen people do BEDMAS. Brackets, so basically dealing with either parentheses or square brackets, because there are different ways that people can enclose things. So brackets, exponents, division, multiplication. Remember, multiplication and division happen at the same time, left to right, so whether we say multiplication, division, or division, multiplication doesn't matter. And then addition, subtraction. So that's a way that I've seen this done. Also, a more newer method that you may see places is gamma or gemma, which is grouping, which takes this even further. Parentheses was very specific. Parentheses was that. And then we had all sorts of things that weren't parentheses that we treated as if they were parentheses. Brackets gave you that or that. But then there were all sorts of other things that we treated in that group, whether they were there or not. Grouping says anything that causes it to group. So we could have different types of brackets. We could have a division symbol here, which means things happen on the top, and so those are grouped together. We could have a radical, which means anything that happens inside the radical is grouped together. So a number of ways that we could have groupings. So that's where this gemma comes in. It says specifically groupings, as opposed to going into one or two items. So anytime things are grouped together. Exponents. So let me put that there for you. Actually, I'm not going to yet. I'm going to do it on the next one. So grouping, exponents. M stands for multiplication and division. So now we're grouping them together and saying, when we get to that step, do multiplication and division, just work your way left to right. And A stands for addition and subtraction. When you get to that point, just do all your addition and subtraction from left to right. The final one, and the one that I've seen most recently, which I kind of like, because these you're like, okay, please excuse my dear Aunt Sally, you've known that for so long that that's embedded in your head. Bedmoss, maybe you've heard of it. Gemma, now you're like, Gemma, yeah, how do I remember that? Whereas this other method is to say gems. Gems. And it takes advantage of the same sort of thing that we did here with Bedmoss, that we've got here, from here, we've got grouping. So we'll do any grouping, followed by any exponents. And I will make a quick aside here and say that exponents, remember that radicals were the opposite of exponents? They undid exponents. Well, radicals can actually be written as exponents. So as I said, multiplication and division are essentially the same operation, right? Addition and subtraction are essentially the same. Exponents and radicals are essentially the same, so they fit into that exponents category there. And then we've got multiplication and division. I'm just going to do mult and div to save myself a little bit of effort. So multiplication and division. And then S stands for subtraction and addition. Subtract and add. So subtraction and addition. Now, the reason I like this better, because it's easy to remember gems, right? Things that are very important, things that are very valuable. So gems. So we have our grouping, our exponents, multiplication, division, going left to right, subtraction and addition, going left to right. So just a number of different ways that we can remember order of operations. So let's put some of these to use and see what happens. Okay, so let's do our first one here. So 11 minus 2 plus 5 minus 4 plus 3. So 11 minus 2 plus 5 minus 4 plus 3. So going through, and we'll deal with gems. I'm just going to put it over here, just as our little reminder. So gems says first we want to do groupings. Well, the grouping I see here is I see parentheses here combining the 4 and the 3. So I still have 11 minus 2 plus 5 minus 4 plus 3 is 7. Okay? So I took care of my grouping. Now I just have the subtraction and addition and subtraction. So we have no exponents, no multiplication or division. We have subtraction and addition, so we start doing subtraction and addition from left to right. So 11 minus 2 is 9. So 9 plus 5 minus 7. 9 plus 5 is 14 minus 7. 14 minus 7 is 7. So we get a result. So we went through, we did grouping first, we had grouping, added those together. Then we didn't have any exponents, no multiplication, division. Subtraction, addition, we worked left to right, so 11 minus 2 gave us 9, plus 5 minus 7. 9 plus 5 was 14, minus 7, and then 14 minus 7 is 7. Now, that's doing it the correct way. What would happen if we just worked our way across? Just to see. So we're going to try a couple wrong ways, and I'm going to do those in red, because this is correct. So what if we did this just working our way across? 11 minus 2 is 9. 9 plus 5 is 14. 14 minus 4 is 10. 10 plus 3 is 13. 13. And that's not right. So that's wrong. Okay? What if we tried to follow the PEMDAS and put addition before subtraction? So we follow the grouping and we say, okay, I have 11 minus 2 plus 5 minus, and we do the grouping, 4 plus 3 is 7. And then we say, okay, addition comes before subtraction, because that's what PEMDAS tells me, addition, subtraction. So we have to do 2 plus 5, so we have 11 minus 7 minus 7. So then we go 11 minus 7 is 4 minus 7. 4 minus 7, oh, that's not good. We can't take 7 away from 4. No, we're already into trouble, right? We're not going to get a positive result, and we haven't dealt with negative numbers yet. So that would be very bad. So these two examples that I just did here in red, those are very wrong. We ignored order of operations, or we got confused in order of operations. So we did parentheses first, turned this into 7, and I'm just going to show you an abbreviated approach to this. I showed it all out. Well, what if we just kind of abbreviate it as we go? Well, I can go 4 plus 3 is 7, so I've got that there. 11 minus 2 is 9. 9 plus 5 is 14. 14 minus 7 is 7. So as you get better at this, you can start to do kind of abbreviated methods and say, okay, put that there. Yep, you got this. Okay, well, we're going to take this and add 5 to it, we get this. And then we're going to subtract 7 and we get this. So that's kind of what you can aspire to, is working through and being able to just kind of do it briefly. It saved me a lot of writing. So as I feel more comfortable with it, I can do things of that sort. Let's try another one. 4 times 3 divided by 2 times 7. Order of operations says that we are going to take grouping first, right? Grouping, 4 times 3 is 12, divided by 2 times 7. No exponents. Multiplication, division that we have, but remember it's from left to right once we get to multiplication and division. PEMDAS, people get confused and they want to do the multiplication first, but nothing tells us to. We're going to work our way across. So 12 divided by 2 is 6. 6 times 7 is 42. Whereas we would have run into problems again if we had done multiplication first. 2 times 7 would have been 14. We would have had 12 divided by 14. At least it would have been a positive number this time. But order of operations says do grouping, and then when we get to multiplication division, work our way left to right. Let's try another one. What if I have 6 plus 7 times 2 minus 4 times 3. So we don't have any grouping here. We have addition, multiplication, subtraction, and multiplication. So no grouping, no exponents, multiplication, division. We only have multiplication there, so we're going to go 6 plus 7 times 2 is 14, minus 4 times 3 is 12. Right? Order of operations says multiplication is going to come before that subtraction. Now I can go across left to right because I have addition, subtraction. 6 plus 14 is 20 minus 12. 20 minus 12 is 8. Well, you're doing pretty well thus far. Let's take it up a notch. And what if we have 8 minus 3 in parentheses times 12 all over 5 times 2. Okay, order of operations says do grouping first. Now this brings out another point to this. We've got grouping above the division, 8 minus 3 times 12. But we also have grouping inside of that. So if you have multiple layers of grouping, work your way out. So we have this grouping up here, but first we've got to do once we get inside that grouping, we're going to do order of operations inside that. If there's another grouping inside that, we're going to do order of operations inside of that. So we go 8 minus 3 gives us 5 times 12 over 5 times 2. 5 times 12 is 60. 5 times 2 is 10. 60 divided by 10 is 6. So working our way through. So we had grouping. Inside that grouping had another grouping, and we did the subtraction. Then we took our multiplication and did that, and down here we had a grouping, 5 times 2, so we did that. And then we were able to divide and get our final answer. Let's take it up another notch. Okay, so 7 plus 1 squared over the cubed root of 8. Well, it looks like we've got addition in here, we've got an exponent, we've got a radical, we've got division. So order of operations says grouping first. Well, grouping, I see a grouping above the division, and I also see a grouping inside of that. So I'm going to do that grouping inside. 7 plus 1 is 8, so I have 8 squared over the cubed root of 8. Well, I still have that grouping on the top, I have the grouping on the bottom. So I'm going to take 8 squared, which is 64. And the cubed root of 8, so I'm looking for a number that if I take 3 of it and multiply it together will give me 8. 2 times 2 times 2 gives me 8, so that's equal to 2. And then, now that I've done my grouping and my exponents, I can do, again, multiplication, division. I've got division. 64 divided by 2 is 32. So it's a step at a time, working our way through it. Okay, final one. We've taken it up a notch, we took it up another notch, we're going to take it up yet another notch, and this is the one where you're going to start, finding walls to bang your head against, your calculator gets tossed across the room, things of that sort, because we're going to add in some decimals and we're not going to make this a quick, easy calculation. So let's say we have 5.2 minus 3.1 to the 4th divided by the square root of 2.1 squared minus 1.3 squared, and do that. So we've got some subtraction. Now let's make it positive there, make it plus. Get a little variation in here. So we've got subtraction, addition, we've got powers, we've got square roots, we've got division. So this is looking fun. So at this point, what do? I go over here and I grab my calculator, right? But I'm going to use my calculator to do the calculations, but I'm not going to plug it all in one shot. I could, but I'm going to take it a step at a time. So I'm going to start by saying I need to take this 3.1 and raise it to the 4th. So I have 5.2 minus 3.1 to the 4th. 3.1 raised to the 4th gives me 92.3521. So that's my numerator here. I've got a grouping inside here, so I'm going to have the square root of, well, I'm going to take 2.1 and square it. 2.1 squared, which gives me 4.41, plus I have 1.3 squared, which gives me 1.69. Okay, well I still have this grouping here, I have this grouping here, so 5.2, oh, this isn't going to be good. This is going to give us a negative number. So, here we're going to run into a problem. So I'm going to do a slight modification. So I apologize for this. I'm going to make this one addition, and I'm going to make that one subtraction. So that becomes addition, that one becomes subtraction. So I changed the numbers, I changed our problem just a little bit, so realize that it's essentially the same setup, but we changed the subtraction that was in the numerator to addition, and we changed the addition that was in the denominator into subtraction, just so it would keep our numbers positive. No, when you're doing mathematics, you can't just randomly change your operations to make things work out the way you want. Yes, as an instructor, I can for demonstration purposes. That's the power of being the instructor as opposed to the student. You figure all the years of schooling that I've gone through, I should get some benefit from it. Okay, so now I have 5.2 minus this 92.351, sorry, plus this 92.3521. So 5.2 plus 92.3521 gives me, I'm going to put it down here, 97.5521. Still going to keep this radical here, and I've got 4.41 minus 1.69. 4.41 minus 1.69 gives me 2.72. And still, I've got this radical here I've got to do, so I'm just going to move up here to continue on. So I still have 97.5521. And now I'm going to take the square root of 2.72. So the square root of 2.72 gives me 1.65 approximately. I rounded that because it actually gave me 1.64924225, whatever. So 1.65 approximately. And now I divide 97.5521 by 1.65. So 97.5521 divided by 1.65 gives me 59.12 approximately. So that's plugging it through step by step. I'm going to put that answer off to the side here, 59.12, and I'm going to erase my steps along here. Okay? And what I'm going to do is I'm going to show you the button presses that I would do if I was going to put this in as one big equation. Because I can do that on my calculator. But what I need to do is, first of all, remember those groupings? We need to indicate those with parentheses. So I would do an open parenthesis, and I go 5.2 plus 3.1 hat 4 close parentheses. Now remember, my calculator is going to follow order of operations. So it's going to recognize that it should do an exponent before it does addition. So I didn't have to tell it to put the 3.1 to the fourth in parentheses. It did that. But it would have taken division before it did the addition, so I had to put parentheses around that. So this right here gave me the top part. Now I'm going to divide. Everything in the denominator is under this radical. So I can put my radical here. So I hit the radical button. Then, depending on your calculator, you may or may not have to put an open parenthesis there, meaning your calculator may give you an open parenthesis. You need to have one, so I'm going to put an open parenthesis here. It's just some calculators actually give it to you, so you don't have to press it in separately. Others, you have to do it. And then I'm going to say 2.1 hat to, or actually I can hit my x squared button, right? X squared, I'm just going to make sure, show that I've got my x squared button, right? Minus 1.3, and I can hit my x squared button, and close parentheses. Now remember, your calculator recognizes that exponents come before subtraction. So it's going to square this first, square that, and then it's going to subtract. Then because of the parentheses, it's going to take the square root, and that's going to be sitting in the denominator. It's going to take the power first, 3.1 to the fourth power, and then it's going to add that to 5.2. And then because of the parentheses, and it's done all that, now it's going to divide the numerator by the denominator. So let's see if I plug this all in one piece, I should get something close to 59.12. The reason I say something close, and I don't say I should get 59.12, is remember when I took the radical, I did round that, and then I rounded my final answer afterwards, so it's possible that could have thrown things off just a little bit. So let's see what happens. So I do this, and I go 5, so open parenthesis, 5.2 plus 3.1 hat 4, close parenthesis, divide, square root, and mine gives me the open parenthesis, so I already have it there, 2.1 x squared button, which just puts a little squared symbol there, minus 1.3 x squared button, which puts a little squared thing there, and I close my parentheses and hit enter, and I get 59.15 approximately, 59.14964,887. Now remember what I said. I rounded the square root in my previous example, right? As I went through it, I rounded it, which means I was dividing by a rounded number when I came up with that. So that's why I came out with 59.12. If I had kept more decimal places, I would have come out with a number closer to this. So 59.12 doing it by hand, and 59.15 plugging it all into my calculator, that's really nothing to complain about. That's pretty good. And that's why we really need to get used to how do we plug things into our calculator. Know the order of operations so we can do it on our own, and know order of operations, because if we don't know order of operations, we don't know that we have to put these parentheses in here, which means you're not going to use your calculator correctly and it's going to give you the wrong answer. If I just, and I'm going to switch over to my red pen for this, to write this final answer down, if I just plug this in as I see it right there, 5.2 plus 3.1 raised to the fourth, divide, square root, 2.1 squared minus, oops, hit the wrong button there. Instead of hitting minus, I hit my negative sign. Minus 1.3 squared, enter, I come out with 197 approximately. So you can see that I came out with the wrong answer. Now, yes, it is somewhat near that, and that's just because this question, the way it was written, there wasn't that much that got shifted by doing that. All this whole denominator was already tied together, which is what saved us. We ended up with 3.1 times to the 4 divided by all of that, and then added the 5.2 instead of having all of this added together and then divided. So since that was a small number, it had a very small effect on it, but still, it's wrong. Right, right, wrong. Okay, so be very careful with order operations. Get practice plugging it into your calculator correctly and knowing where you need to use parentheses, when your calculator gives you parentheses, and making sure that you know which buttons to use.